John, it seems to me that with all the catastrophic events we had going on during the flood, laying down all of the sedimentary layers, and then we have all of these catastrophic events that happen after the flood. Right. As a geologist, how do you know where one ends and the other begins?
Yeah, that's a really good question, Del. And creation geologists have struggled with that, thinking through those things. One of the things that we know that happened during the flood were catastrophic processes. And so a lot of geologists have thought, well, anytime we see catastrophism, that equals flood. But I'm not sure that's always the case. And so one of the approaches that I've taken, and primarily looking at North America and some other places too, is we know that the flood was a worldwide event. And so when we see layers of rock that extend across the entire continent, that's likely a flood process.
Like we found material from the eastern edge of the United States all the way over here.
Some of the rock layers that do that as well, like the Tackett sandstone that the folds are in Grand Canyon, that same sandstone layer, we can trace that into Colorado, not too far from where you are. I've seen that same rock layer in Wyoming. I've seen that same rock layer up here in Wisconsin. It's in Ohio, but it's not at the surface. But I've seen it in a state core lab where they save rock cores. And I went to the library one time and asked them to pull up the section from deep down in Ohio, and that rock looks exactly like the Tackett sandstone, right above the Great Unconformity. And so that's one clue, I think, that we have a flood rock is, looking at just the extensive nature of it. I think flood rocks are more typically going to be continental wide.
Yes, that makes sense.
When we get into post-flood times, we're going to have some uplift here. And so, a process that's happening here, it's going to be catastrophic, but that catastrophe is not going to reveal itself over here. It's going to be more isolated in this area. And so, although, post-flood rocks can be catastrophic and they can be, very impressive when you're up close, they aren't anything as extensive as some of the layers that were made during the flood.
Okay.
Another clue that we have is the flood was a marine event, right? It was the ocean water on top of the continents. And so there's particular things that we can look at in rocks. Marine animals, for example, when we find marine animals buried on the continent, that's obviously flood. And as we go up through the section of rocks, there's a place in the rocks in North America where you stop seeing marine animals and only see terrestrial animals after that. And we think that's probably another good and obvious indication that the flood's over.
Would that be like the Bonneville Lake then?
Yes.
That we'd say if that's fresh water, then that's probably post-flood?
Right. When we look at some of the fossils in the Bonneville Lake sediments out here, those are primarily freshwater fossils. We see some saltwater in there. There are some saltwater basins, but primarily they're freshwater basins.
Yeah, that makes sense as well.
The other thing that is a little hard to pick out, but I think makes a lot of sense, is that in flood deposits, we don't see complete ecosystems typically buried together. As we look at the famous dinosaur deposit in Dinosaur National Monument, where the dinosaur bones are scattered on the wall there, you see all these dinosaur bones, and they're big, sauropod dinosaurs and whatnot that would have eaten a lot of vegetation, probably tons of vegetation every day. But then you look and there's no vegetation exposed with the bones. There's a single tree trunk in that expanse of wall that it's hundreds of feet in size. I think that's indicative of flood deposit. You don't see complete ecosystems. But after the flood, in places like up here in the Green River Basin up in Wyoming, in some of these basins out here in Nevada and California, you see complete ecosystems. So when you're near the shore, you see footprints and you see algal growths and so forth that would have happened in shallow water. And deeper water, you don't find those things, and you find some fish fossils and some other things. So you can actually put together the entire ecosystem where plants and animals would have been, and it all makes sense.
Sure,
And you can
yeah.
draw those things out along with the sediments, but you can't necessarily do that during the flood. And so the process that we do is we look at many of those things, and we say, all right, this deposit's really extensive. This deposit has marine fossils in it. This deposit is fairly thin compared to its, widespread extent and so on. We would call those flood deposits, and we look at where those kinds of things stop and then where they transition into other things. And we, put the boundary at that transition.
So it seems to me then that that boundary, if we were interested in wanting to know exactly where that boundary was, would be different in different places all over the world.
Yes.
Depending on what kind of catastrophic events and processes were occurring in that region.
Yeah, biblically, we would define the flood being over when Noah steps off the ark. That's not a geological thing. We can't tell over here in North America when does Noah put his foot in the ground, right? And so we have to depend on geological things. And so I think the biggest and most important thing is, at what point is all the marine water gone? When do we stop seeing widespread marine deposits? And it's there where you put the boundary. Now, you can have other things piled on top of that and obscure that boundary, which I think is very likely and has happened in many places. Sometimes that boundary is eroded by post-flood processes. But we need to look carefully through the whole section to pick that point in the rock record. Let's go down and look at this other map.
Okay.
Del.
This one down here?
Yeah. This is
A lot of color here, John.
yeah, it's what we call a geological map.
Okay.
Lots of colors on here, and it's complex, right?
Yeah.
We see a lot of patterns, a lot of different colors, and so on. And each one of these colors represents a different set of rocks.
Okay.
And one of the main colors you see on here is this green color. These represent Cretaceous rocks, and we can see them in a variety of places here in North America. These are rocks that extend across the entire continent. In other words, this is like a thin blanket that was laid down across the whole continent. And that thin blanket has marine animals in it, so we think that's a flood deposit. In fact, some of these green layers in here are chalk deposits, and this layer not only extends here in North America, we can find it over here in Europe, like the chalk cliffs of Dover.
I was just there a couple of years ago, yeah.
Yeah, and so that's one of the ways we know that's a flood deposit, because it not only extends across a continent, oftentimes we can trace it to other continents as well. Now, this is one of the last layers that we think was laid down during the flood, and we end up with some of these browner layers up here, and these layers were laid down in basins. In other words, we had to have some mountain uplift. The mountain uplift would have bent and faulted and contorted some of the layers that were down below there. We had some mountain uplift, and then we had these brown layers laid down in between those mountains.
So these would be post-flood
That's
you're
right.
talking about.
So you get mountain uplift, and those mountains are going to be above sea level now. We get a whole continent that's rising up above sea level. When marine water is gone, the flood is over, right? And so we think these basins are post-flood. They're still going to have some catastrophe, evidence of catastrophe in them. But because of the fossils that we find there, because of the complete ecosystems and so on, and because they're not blanketing the entire continent, we think they're post-flood. So this map kind of shows us the extent of these layers, but we can also look at a cross-section to see what's going on under the surface. What we want to look at is cut a slice down into the earth and look at the slice.
Kind of an edge view of it.
Yeah, an edge view.
Okay.
And so that's what I have on this screen. This is a map that was published in the 1970s, And the geologists have drawn several what we call cross sections. And so these are edge views. A lot of these edge views are very similar. And so I'll point to this middle one right here. Notice the rocks, how they're bent and contorted and folded underneath. So this is underneath one of the Green River basins in Wyoming, the southwest corner of Wyoming. And these rocks were bent as the whole western portion of the United States was lifted up, and they made these folds. Sometimes there's some breaks in here. These breaks we call faults, but you can see they're folded, and these rocks used to be flat. These are some of the blanket layers that extend all the way across the United States. So the green layers that we were looking at the previous map, those are some of those are right in here. Here's some of the layers right below there. So these layers we can trace right across the continent, but then we have mountain uplift that takes place. We have some erosion that takes place, and we have a basin that forms, and water collects in that basin. And so you can see the layers right in here are flat compared to the folded and contorted layers. And so this is a basin that formed immediately after the flood was over, when these mountains were lifted up and the waters drained away. This basin formed, and it began to collect water in it like a lake.
Yeah.
And in these rocks, we find fish fossils, we find plant fossils, we find bird tracks and other things. And we think that these rocks right here represent some of the very first post-flood rocks.
It seems clear to me, help me if I'm right or wrong here, it seems clear to me that there is obviously a great difference between what was going on here and what is going on here.
That's right. Think of all the forces that have to be active to contort and bend and fault all of these rocks. There's an immense amount of mountain building activity that takes place to make that. But then these rocks get laid down, and you see maybe a little fault going through there, a little fault going through there. But primarily these rocks are nice and flat, and they're still flat today. Which means that, you know, once these sediments began to be deposited in that basin, the mountain building in there was primarily over. And so notice that these layers are all kind of sheared off right in there. They're flat.
Right, yeah.
And then you have layers laid on top of that. And notice that the folding and the faulting largely does not go into these orange and yellow layers up here.
And that makes it very clear, at least in my mind, that whatever processes were that were going on here,
that's right,
that was the faulting and the folding is something entirely different than the processes that were happening up here.
That's right. And so I would put this folding and faulting primarily during the flood and the processes that lifted the mountains up at the end of the flood. I'd put those in there. And because these are flat lying, that says those processes are done.
Yes.
We also see the fossil fish and fossil plants and so forth of the Green River Formation in these layers, and these orange and yellow layers up here indicate a full ecology there. We see plants and birds and things like that of stuff that it looks like it was an in-place environment that was fossilized there.
And that was part of your criteria then, that this appears to be much more local?
That's right. These are more local types of deposits. They don't extend across the continent. Now, what I want to get to, Del, is the same process that made the folds and bends here, we're working in Grand Canyon.